multiply by a negative. The sign, the direction of the inequality changes. Okay, so let's do some algebra with inequalities. So we'll add e to the 2x to both sides. Adding, subtracting stuff to inequalities, that doesn't matter. Just one more thing to keep track of. So I have 3 greater than or equal to e to the 2x. That's fine. Now I take logarithms of both sides. It turns out you can do this without a problem. So I'll take logs. That does not change the sign. So ln of 3, remember that's some number. Natural log and e, their inverse functions, they cancel. And I have ln of 3 is greater than or equal to 2x. Lastly, divide by 2. Now just be careful, we're dividing, but not by a negative, so I don't need to switch the sign. So last but not least, I have, we'll do it this way, x is less than or equal to the natural log of 3 over 2. Just, and that's be done here, but just the way sometimes if you check answers in the back of the book, or do something like this, just get used to seeing this different ways. You can see this 1/2 times the logarithm of 3, and then because it's a number in front, sometimes they bring it upstairs, it becomes ln of 3 to the 1/2. You might even see this as ln of root 3. So however you want to write it, x has to be less than that. So any number smaller, less than or equal to this value, is a perfectly fine thing for doing. Okay, so that sort of did part A. Here comes the rest of our multi-step. I need to find the domain of the inverse. Of course, to do that, I have to find the inverse. I have to find the inverse. So they're asking for a couple things. So let's see that over here. Okay, so remember our 4-step process. Step 1, write the function as y equals square root 3 minus e to the 2x. Step 2, swap the x's and the y's. So it becomes 3 minus e to the 2y. Now comes the fun part, solve for y. Y is trapped, first and foremost, under a square root. How do I free it? What do I do to undo a square root? I square both sides. Okay, let's move the e over. So I get e to the 2y equals 3 minus x squared. So just move some things around. That's okay. Remember, we're trying to solve for y here. It's a little counterintuitive. Usually we're used to solve for x. But I got to solve for y. How do I do that? Well, it's trapped with an e in the base. So let's take ln to both sides. And then these guys cancel. So you get 2y is equal to ln 3 minus x squared. Do not distribute the natural log into both pieces. That breaks algebra. Log does not distribute. You can check your rules. If you have them handy, you're kind of stuck with this. It is what it is what it is. So finally, log is 1/2 times the natural log 3 minus x squared. The last step in our 4-step process, once we have solved for y, is to write it as f inverse. Use the proper notation. So this is ln 1/2 ln 3 minus x squared. So there's the inverse function. And now, of course, we have to find the domain of this inverse function. This is not as bad, because remember, the logarithm of the domain is positive numbers. I just need 3 minus x squared to be strictly greater than 0. Notice the difference. The last one under the root, you can equal 0. In the logarithm, you cannot. Move the x squared to the other side. You get 3 has to be greater than x squared. There's a couple ways to see this. X squared, here's our little parabola. So the question is, where is the 3 on the map here? For what values of x? What values of x is the parabola less than? Is the parabola less than 3? So if we play around with this, you'll see it's I don't know if this is what we do, algebra, plus or minus, negative root 3 and positive root 3. So x can be inside the interval, has to be parentheses, because it's not greater less than equal to or greater than equal. Negative root 3 and then positive root 3. So however you want to solve for that, that should be the answer there. So this is a multi-step problem. It uses a bunch of information. It's a little trickier because it has inequalities. These are the kind of questions you're going to see, the tougher questions that you might see on tests or things like that. So go through this one, cover it up, start over again if you didn't get this one right or were confused about steps, and then of course let me know if you have any questions. Okay, good job. See you next time. All right, everyone, and welcome. We are going to talk about the exponential and logarithm function and how to implement them and how to graph them using Python. And they all come from the library, the math library. So the first thing we're going to want to do is to import the math library. And then that gives you access to the exponential function, and it is written as, let's do math.ext.
Thanks for joining me here to take a look at generative AI code. This exercise is completely optional, so if for some reason you don't complete it, that's totally fine. You don't need any of this to complete the rest of the course, but I hope you take a look at the code and have fun with it. Let's dive in. If you're accessing this on a desktop, then probably to the left of this video will be a code region that looks like this. Or if you're accessing this on a mobile device, then this may be on top of where you're watching the video. But you see this coding region with instructions that says for each of the 2 code cells below, click on the cell and hit shift enter your keyboard to run the code. Or on mobile device, there may be a play button that looks like this. That if you press the play button, will have the same effect as hitting shift enter on your keyboard, because it's harder to hit shift enter on say a smartphone's keyboard. So let's do that. Step 1 of the instructions is I'm going to go to code cell 1 by clicking my mouse on this green region. And code cell 1 sets up the program environment to use code to send mouse to the next output service. So I'm clicking my mouse here and I'm going to hit shift enter right now. And this number just changed to 1 to indicate that this is the first code cell that we just ran. In case you accidentally run this code cell twice or something, don't worry about it. It won't break that way. After having run code cell 1, let's go to code cell 2. Code cell 2 will define a prompt that will classify the center of the restaurant review. And so here we set the prompt to equal to classify review as a positive experiment, but that was really tasty. And what this does is it defines the prompt. This is the prompt. And then it gets the large language model response to the prompt, and that's your response, and lastly, it will print out this response. So that's what these 3 lines of code does. It defines the prompt, it gets the response to the large language model, and it prints out the response. So I'm going to hit shift enter. Remember, I have to click on the cell to select the first code cell 2, and hit shift enter, and this runs, and it says positive sentiment. So please feel free to pause the video and try yourself. Remember, click on the first code cell, then hit shift enter or the play button, then click on the second code cell, and then hit shift enter or the play button. After that, I encourage you to try changing the prompt. Change it to whether you want to try again. So instead of the banana pudding was really tasty, maybe I'll say the banana cake was delicious. Click and shift enter game. And oh good, that's also a positive sentiment. Notice this now says 3 because this is now the third time I just ran the code cell. Feel free to change this to some other food review, pause a minute. I just ran the code cell. Feel free to change this to some. Another food review, pause a minute sentiment, and see what results you get. When you're done with this, you can click on the nav bar to activity 2, which will take us to a second, slightly more complex code example. Thanks for joining me here to take a look at